Howdy, folks, and welcome to your storm chasing forecast show for Tuesday, August 25th. I am Gabriel Harber, and I have the privilege of once again being joined by Coach Hunter Fowkes. How's it going, man?
Good. Happy to be here. A little sad about this setup as I was a little excited about it a few days ago, but I think there's still some good storm chasing to be had, and we're going to get into that soon.
And I don't know if you noticed, not to toot my own horn, but this is the third straight time we've been on a show together. This will be the second forecast show, and then an office hours that we are actually as a group coaching session that we recently did, where I got your name right 3 times in a row. So I do believe that is a record. I'm not keeping track or anything. I just a little bit of flowers would be nice.
Progress. I love it. Progress. Good job.
Thank you, my friend. Thank you very much. So I see you've got the categorical outlook up already on your screen, so I will let you take it away and tell us what the big picture is that we're looking at today.
Absolutely. So we've got a slight risk out, predominantly over the Central Plains, with a much larger marginal risk over much of the Central Plains into the parts of the Midwest and up into the Western Great Lakes region. Predominantly looking at mostly hail and high winds, but maybe we'll be able to find a tornado or two if we're lucky in some niche areas. Should be kind of fun. Two different types of setups that we're going to get into. All right, so let's go ahead and just get started here. Just looking here at the categorical look here. Here's the slight risk. Generally, we've got a 2% risk that is up here into the Western Great Lakes, kind of the upper Midwest. Overall, a 15% SIG-1 risk out in the Central Plains here, 15% there in the core, with a 5% non-SIG risk up here. And overall, just a broad stroke 5% hail risk as well. First, we're going to talk about the northern setup here, the 2% tornado risk that SBC has noted here. We're going to take a look here at the wrap. We're going to pull up the previous 21Z run here so we can just get a little bit nicer, clean view through a longer model suite here. We're going to start up top here looking at 500 mil or 300 millibars, excuse me. This is going to be a fun little setup, and I was actually excited to talk about this one specifically because this is kind of similar to what we call a cold core type of setup. Now, this is kind of not quite a full cold core, but there are a lot of similar elements, and we'll kind of talk about that. But we're going to look into what this setup may potentially be, and there are some caveats towards this setup as well. But first things first, here at 300 millibars, we see a well-defined trough and a nice cutoff, or excuse me, a nice well-defined low here at 300 millibars, way at the top of the atmosphere. Looks like it's going to start progressing in. Overall, the overall kind of pattern across the U.S. is a big old high pressure dominating the southern U.S., and this system kind of riding the top edge of the system. This bulk flow is going to be the kind of cause of the severe weather going both in the Central Plains and here in the northern Midwest and Great Lakes region. Here at 300 millibars, we've got a nice closed low that should be rolling into the upper Midwest here. And going into the morning here, into the early afternoon, it pretty much just rockets right into the US-Canada border here. And by the afternoon, evening, starts really impeding into this area of interest that we had denoted with that 2% tornado risk. And the first thing that I want to point out is we are obviously going to look for our jet dynamics, right? That should be the first thing we should be looking at in any of our forecasts. And while you do have multiple little jet streaks in here, you've got another one riding the base of the high pressure ridge. There's a lot of different flow coming in here, but generally speaking, with all of this flow, you are getting spreading apart of the wind vectors, and that's the most important part. And we are getting a vacuum effect generated over this 2% risk area that we're interested in. So it seems to go aloft with this coming in closed low, that we will develop lift from aloft, so there shouldn't be an issue with pulling up air from below and generating thunderstorms. So pretty good sign to be seeing here. If we step on down to 500 millibars, again, one of the important rules of when you're looking for a potent setup is what's happening with the 500 millibar flow. We want to see that punch right into our area of interest. At 500 millibars, with this being more of a cold core, normally you're actually going to see your 500 millibar flow actually mostly miss the target area of interest, and this is actually seems to be following suit as well. So we see this nice low parked out over here, nice closed low. As you can see, that height line is a complete circle. And we see the stronger belt of flow does seem to be a little displaced to the southwest, but this is actually quite normal for more of a cold core type setup where the stronger forcing usually is a little bit more relegated away, more for that open warm sector. And for the area of interest, we are again looking in here Seems like we get a little bit of flow, still 40 knots, 30 to 40 knots arcing in. So this is still sufficient flow for this type of a setup. An important thing to remember with cold cores is that it's very important that the surface low and the 500 millibar closed low are very close together, generally 200 miles or less away from each other, and we'll go down through the surface and we will know that they are actually pretty close. The surface low actually ends up being somewhere roughly around in here, and the upper level low seems to be pretty close as well. So if there's a lot of cold air involved in this system, hopefully the distance requirement seems to be being met here with a mostly vertically stacked system. Even though this system maintains a nice positive tilt through this storm, that's through the event, this is still a modestly decent mature trough swinging on through. So now going into the setup, we want to look at the south side as well at 300 millibars as well and see kind of what the pattern is going to be going into this. So going into the early morning hours, we see some flow traverse this big old high pressure down here to the south. By the morning, we still have lots of flow kind of anticyclonically rotating through the central and north central US. And by that afternoon hours, we seem to get a little bit of a shortwave trough to develop in the higher terrain out here over parts of Wyoming, the Black Hills in South Dakota, down into Colorado. It seems like a little bit of a shortwave develops with some modestly strong belt of flow through here, generally moving west to east across the zone. So that seems to be the impetus of what's going to cause lift across the zone as this flow basically arriving into the area of interest and likely generating just a little bit of lift here across the eastern high plains and central plains here at 300 millibars. At 500 millibars, again, what we want to see is what's happening with our flow, and we want to see the strongest flow kind of punch into our area of interest. And seems like we are kind of getting a little bit of stronger, locally enhanced flow kind of coming off from the northwest into the central plains here, eastern high plains. Not very strong, looking at about 20 to maybe 30 knots locally. So this is some pretty weak flow, nothing too necessarily impressive, maybe just enough to get a little bit of bulk shear into this system. But seems like we're going to have two different areas of interest based off this 500 millibar pattern that we should see some decent weather, maybe more locally enhanced by the stronger system up north, and a developing shortwave in the afternoon hours. That should kind of kick off some thunderstorms in the eastern plains and central plains.
We good to go there?
Yeah, rocket.
Beautiful. Love the analysis, Hunter. Especially, it looks like you still may get some of that. Well, there might be still a little something yet. I wouldn't count yourself out too early.
Absolutely. I'd love to see anything. At this point, I'd just ask for rain.
Yeah, just rain for the yard, right? You're a dad now.
Yep. Hey, my garden needs it. My lawn needs it. Hey,
I'll tell you what all the folks at home need. You like that segue? They need a Weatherfront subscription. If you are enjoying this product that we always use for these forecast shows, that is the browser app for Weatherfront. It comes packaged with a mobile subscription, and Weatherfront is now available on Android. So if you go ahead and purchase a subscription on your mobile device, you're going to use your credentials to log in on the browser app. You'll also get access to the desktop app. I'm not sure if that's available for Windows computers and Apple computers. I think it is. I'm not sure. You'll have to check on that. But I know for a fact the browser app is available and, of course, the mobile app. So link down in the description for that. Best product out there. We absolutely freaking love it here, as you can see. So, Hunter, I'll toss it back to you, and you can continue your journey down into the lower levels of the atmosphere.
all right, everybody, let's get into it. So, first thing we're going to look at now is we're going to drop down in our levels to 700 millibars. We want to see what's going on with the flow here and specifically look at temperatures, right? An important layer, we look for capping as well as any shortwave impulses. It's a very important layer to be paying attention to in our forecast. Obviously, we're going to start up here north with the closed low traversing through the upper plains of the United States. Very strong system, well-defined closed low, and a really nice belt of flow at 500 millibars by the morning hours. As we traverse into the afternoon, again, like we talked about at 500 millibars for more of a traditional cold core, seems like our stronger flow does deflect a little bit more southward as the straight jet kind of pushes straight into southern Minnesota, northern Iowa through the afternoon. But we still seem to be getting actually some decent turning with height across here. Maybe towards the Twin Cities, more of a westerly wind, but up here in the kind of northeast part of the state of Minnesota, we actually start seeing a little bit more backing, maybe west southwesterly winds here as we get closer to this center of circulation up here at 700 millibars. So it seems like we're getting a little bit of turning with height as we've gone from northwesterly flow to more in this zone. So it seems like we're getting a little bit more locally turning winds here in this zone. Again, why SBC denoted a 2% seems to be that there's a little bit more turning of winds with height. If we look down south at 500 millibars here, as we compare our two different risk areas, seems to be that we don't really have too much flow here, right? So seems that despite maybe a little bit of locally enhanced pockets, maybe this is a little bit convective contaminated here with some thunderstorms. Seems like pretty much winds are all going to be out of the northwest at about 10 knots or so. So seems like we're getting a lot of very straight hodographs here and maybe some shortened hodographs here, which makes me think as we've been working down that our area of interest here in the Central Plains may tend to be more of a MCS type feature, mainly because we've got a lot of very similar flow that's all relatively weak, all pretty much traversing the same area. So just off of these couple levels, I'm already thinking shorter hodograph, maybe a little bit of a straight hodograph. So maybe favorable for more so hail, but we'll have to look into some thermodynamics, which that's a great segue. So let's take a look here at 700 millibar temperatures. We want to look at what's our cap going to be as we go into the afternoon. By 3 p.m. here, we don't have hardly any cap up here in the northern mode. No surprise here. It's common with cold cores that you don't get too much of a cap here. I would personally like to see a stronger or warmer layer here to help kind of keep the instability at bay or increase the instability but keep the storms at bay that kind of develop into the afternoon. So looking at this with a 2 to 4 degrees Celsius, 700 millibar temperature, you're probably just going to auto-convect any type of instability that's in the area. If we even look down a little further south into central Minnesota, we're looking at 5 degrees Celsius. Pretty much everything in this northern mode by the early afternoon, we should expect thunderstorms to probably develop in this region. Looking further south, seems like we've got a much stronger cap in place, although given that I've already cheated and looked at some of these soundings, doesn't look like there's going to be too much of a cap. This should be pretty easy to break with just thunderstorm instability alone and just a little bit of a jet impulse kind of coming in over those Rockies that we talked about earlier. So even though these are some decently warm temperatures for this time of year, we're going to have probably some pretty steep lapse rates and a well-mixed profile out here. So these warmer temperatures really aren't going to be too much of a big deal to overcome. We'll likely see multiple clusters of storms here, and we'll get into that as we work our way down. Now we're going to move down to 850 millibars. We're going to first look at the wind profile. We want to see what's kind of going on with the low-level jet by the afternoon. We see that our close low here to the north is extremely well defined, vertically stacked system, and we see that flow come in. By the afternoon, it seems like it weakens a little bit, but we do get this lead impulse here of about 20 to maybe 30 knots locally, just shy of 30 knots here of a southwesterly, maybe south-southwesterly low-level jet. So seems like we're getting a good solid zone of some turning with height as we've been working our way down through the atmosphere, right? As we've looked at aloft again from the northwest, then at 700 millibars, we were out of the west-southwest, and then here at towards near the ground, we are now out of the southwest. So definitely getting some nice turning with winds of the height. So I would expect some type of turning in the hodograph or maybe some sickle shape feature in the low-level hodograph if we can get a good sounding out of this kind of core here. But as the afternoon goes on, this does kind of displace off to the east. And I do think that if you do get multiple rounds of storms, this initial pulse will probably be the more favorable area for a tornado or two with this more veered flow. But if we look back west, if we get more additional storms, the flow begins to veer back more westerly. So I think we start losing that stronger low-level turning with height. And I would expect to probably develop more maybe isolated hailstorms with anything that is behind this little lead wave or this lead jet at 850 millibars. Looking back south now, we want to see kind of what's going on down south, or do we have any hope or prayer of a low-level jet here? And based off of the overnight, seems like we've got some northwesterly flow that kind of tries to flip around. Pretty much light and variable through the morning, and by 4 p.m. seems like we get a little bit maybe of some locally backing here behind some system, but not too strong of a low-level jet overall. So I'm not expecting any major severe weather here based off the low-level jet alone. But we do see there actually is some decent low-level turning here, which is actually a little surprising. Seems that flow goes from pretty much predominantly out of the northwest, probably behind some type of system, to actually banking a little bit back more up towards the southwest. So immediately for the forecasters here, that should make you think, is there some type of boundary potentially in place here that could be of interest because there's something that has turned the winds completely out of away from our area of interest and have now come right back. And I'd be very curious to see what's kind of happening maybe up in here through the day. Maybe we get some locally enhanced boundary here. But otherwise, weak, low-level jet here, so nothing too impressive. I don't expect anything too spectacular here. But hey, at least a good sign is that we're getting some turning of the winds here as we get into the afternoon, evening hours. So that should help enlarge the hodographs maybe a tad, give them some stronger low-level inflow. So now let's go ahead and get into the fun stuff now at the surface. First thing we're going to look at is 2 meter dew point and wind. This is my favorite thing to look at generally because we want to see what's the instability looking like, what's the moisture going to be looking like, the content of that, and we'll go from there. Starting up north here in the morning, we see a really nice plume of mid 60s to potentially upper 60s dew points feeding in. And I'm going to start drawing some boundaries here because this is going to be important. Looks like our general center of circulation is way up here, stacked underneath the low. So perfectly vertically stacked system. And we get a bit of a occluded boundary that rides down this way, poorly drawn, but just generally along this moisture axis. And the overall cold front seems to bend back off this way, and the overall warm front is this way. Now, important thing, and maybe you're asking why I'm going through the effort to point these out, these potential boundary locations out. And the reason for that is I mentioned that this setup is similar to a cold core setup, and boundary locations are very important. And a key feature to pay attention to is what's happening at the surface and what's going on with those boundaries. Generally, a cold core setup, you'd want to be targeting the pinch notch point where the cold front, warm front intersect because this seems to be a really nice zone where there's going to be some substantial stretching with height, and you generally get some good turning with height. And that's no surprise here. We can look at the surface and see that out of the west behind them, this occluded boundary, we got westerly winds and dew points seem to fall off. And ahead of this boundary, we have south-southwesterlies. So we've got some really nice turning of the winds with height along this boundary by 2 p.m. I believe this is mountain time, so 2 p.m. mountain, 3 p.m. east or central time, excuse me. So it seems like we've got a nice zone here where we look for some stronger low-level turning where, like we talked about at 850, that there actually seems to be some substantial turning with the winds with height as we get into this like northeastern Minnesota region and along the lakes. So seems like this could be a little interesting thing to be paying attention to. But this setup gets complicated as well because it isn't just the boundary itself. Another thing to pay attention to is we have a large body of water, which is one of the Great Lakes that sits right over here. This lake will often produce a boundary. And if you notice, the winds are coming out of generally the southeast, or they are actually trying to push in towards Duluth here as well. So we probably will see some type of surface boundary along the lake somewhere. This, I think, might be a really key thing to be paying attention to if you're maybe a local chaser in Minnesota, or if you're a diehard professional chaser that wants to go out and fight the tornadoes in the trees. I think this is going to be an important thing to pay attention to is not only what happens with this occluded boundary, but also pay attention to storms that maybe fire here right along here and try to traverse eastward or southeastward towards this potential boundary riding along the lake. It could potentially locally enhance your winds and develop a little bit better of a temperature gradient, and maybe we can see an enhanced tornado potential somewhere near the Duluth area along this boundary. I think this is a fun little setup here that we could be paying attention to and see kind of how this sets up. But overall, looking at other things thermodynamically in the region here before we move on, surface-based cape going into the setup looks like we've got plenty of instability. It's summertime. This should be no surprise. Overall, 3 cape, again, large 3 cape right in the area of interest, just ahead of that occluded boundary, if you remember. So there should be plenty of instability to work with here. Bulk shear, we want to see generally 25 knots of bulk shear to help develop those supercells. We want to look for that parallel to the boundary type of shear vectors because that helps encourage supercells. And if you remember, the boundary is something like this. And seems like we've got pretty much perpendicular winds across the boundary with 25 knots to pushing 30 knots or so ahead. So I would expect cells, maybe a couple multi-cells given the weak bulk shear, but I would expect maybe some small supercells in this type of, maybe transient supercells is a better word, in this region here. One negative thing, though, that I do want to point out that I don't really like about this setup, and something that's very important with cold cores, is we need lots of cold air aloft. At 500 millibars, we want to go right back up. We see that temperatures here are really only getting to -14, -15 right in the core. That's solid. The issue is that doesn't get over our area of interest. As you notice, this is 6 or 7 p.m. Mountain Time, Central Time. So we're not getting much of this cold air really mixing into this area of interest until about maybe 4 p.m. We get about -12 degrees Celsius aloft. So that's going to be a negative aspect to this. And I don't expect to have very strong lapse rates through all of this. Let's go ahead and just set this at 3 p.m. Mountain, 4 p.m. Central Time. Go ahead and pull a sounding here. And what do we see here? Overall, this is actually not too much of a surprise, right? We talked that there's not so much cold air. At 500 millibars, temperatures are hovering just beneath -10 degrees Celsius. Right here, this specific one is about -12. Overall, this whole profile is very saturated. I don't expect very steep lapse rates at all with this setup, and I think this is going to be a negative. Usually in more traditional cold cores, you get this big advection of an EML. And as we all can clearly see here, there is not an advection of an EML at all. This is a very saturated profile, so there may be lots of cloud cover involved that will probably hamper the surface heating. And even this wrap model here is indicating 73 over 66. This is a very moist environment. You're still developing plenty of instability. With small cells, it's a good thing that this is actually going to be rather moist, so these small storms should be able to thrive and not die off too easily. We are getting a decent bulk shear, like we saw, the 25 to possibly 30 knots of bulk shear overall, and a fairly straight hodograph. We do get a little bit of a turning of the winds with height by 4 p.m., 3 p.m. here across Minnesota here. I am curious. I'm going to pull some soundings off of the storm relativity of 3 kilometers. We do see, again, kind of by the lakes, where we get maybe a little bit more shearing underneath that 850 millibar jet. So I'm just going to pull a sounding right here along the lake, maybe in this core of stronger helicity here to see what this looks like. And yeah, we do see that towards the lake, we start seeing much, I'm going to say relatively stronger low level turning with the height through about 2 kilometers. So these shallow, maybe weaker overall thunderstorm updrafts that might be tendency to be mini and smaller are going to be concentrated closer to the ground, but seem to experience maybe a little bit stronger of turning here. So I think with all of this in mind, I don't think it's too out of the realm of possibility to expect maybe a tornado or two out here near the lakes, maybe in far northeastern, the few northeastern counties in northeast Minnesota, maybe tailing into northern Wisconsin here, as depending on where that kind of lake breeze boundary kind of sets up. So seems like a 2% risk here is pretty fitting. I don't expect many storms here to be capable of producing a tornado, but maybe there could be a couple. All right, so now we're going to take a look at the kind of thermodynamics and other profile parameters down here of the southern mode. Generally speaking, we should have plenty of moisture in the area, but a key note to remember is that there is going to be an expectation of an MCS to roll through. And this is pretty well defined even in this wrap model here, where you can see that there is northwesterly winds here in an arc like this. And as I draw this, this should also make your mind kind of peak, because if you draw lines like this on the surface, these are definitely going to be boundaries. And an MCS is expected to blow through the central plains, beginning maybe with some storms that are supposed to be ongoing here across northern Nebraska, southern South Dakota, and some develop overnight in eastern Colorado and progress southeastward into Kansas. Now, this is going to be a negative because this MCS is forecast to mostly plow through the instability field. The wrap here, though, admittedly, actually doesn't push this as aggressively as maybe other models do. And actually, we're going to take a second and jump models here just to compare really quickly this surface field. And if we look at the 0Z HRRR here as a comparison to the wrap, we see that clear MCS just plow through, jump all the way down into maybe dying out across the panhandles here by the early morning. And the HRRR is very negative, all this. Now, there is plenty of precipitation that seems to be kind of sitting here out over eastern Colorado into western Kansas, and it turns into moisture. So, hey, despite having an MCS blow out all your moisture, seems like maybe this heavy precipitation might help keep the low-level moisture hanging around behind the system. So kind of janky, a little weird. I wouldn't be surprised if the HRRR solution verifies here, where an MCS plows through and really kind of cuts off all of your moisture, and then you're kind of just left with whatever wind field is kind of hanging around in this zone. The HRRR here continues this MCS, and actually you can see that the HRRR loves to mix, and no surprise, and if this actually does occur, I would expect this HRRR solution to probably be correct, where that shallow moisture generated by heavy rainfall begins to erode very quickly as it overturns. But seems like we get thunderstorms to redevelop there, and you can actually see that despite all of this dry, overmixed air, which is probably a bias of the HRRR itself, we do still seem to generate storms in the wake of this MCS. And despite this being a big pooled off, probably cold pool air, seems like we do get this kind of boundary here and maybe a boundary kind of tailing back up here into southwest Nebraska. That I think these are going to be the two key feature zones to watch for thunderstorm development through the afternoon. Personally, I think this one is going to be a little too far removed from the overall flow aloft. Remember, we are deep under the high pressure ridge at this point. Probably not going to be all that good down to the south. You'll probably get a few very high base storms, especially if dew points mix this hard. But further north, it seems to be you're still relatively close to some type of returning moisture, maybe from the east, kind of sloping back into the higher terrain of southwest Nebraska here. I think this will be a kind of an interesting zone to watch for as we do get a little bit of flow traversing off of the higher terrain of Wyoming. And it seems like maybe if we can get those maybe easterlies, maybe back east southeasterlies as flow kind of returns behind the MCS, we might actually be able to get a little bit of enough turning of the winds and a deep enough bulk shear to develop a few supercells that could actually maybe have a chance of producing a tornado. Even though SBC has not denoted that there is a specific tornado risk here, I wouldn't be surprised if in the morning hours, if this looks better, that they add maybe a locally enhanced 2% here. But up to them to decide what they would like to do. But I wouldn't be surprised. And if I was a chaser in the area, I would be kind of watching what happens in this Panhandle, Nebraska, Southwest Nebraska, Northeast Colorado, Northwest Kansas region. Overall, looking at some parameters, right, just like we did up north, seems like the HRRR tends to blow through all the instability. That's no surprise. You can see the MCS really chunk through it all, and then we get some redevelopment instability. Not too much, not very strong instability. Overall, looking at about maybe 2,000 joules per kilogram at most in the region. Enough, but not too much. You can definitely see that the HRRR wants to keep this higher instability way off to the east overall. Looking at general helicity here, let's pull up 0 to 1. Through the afternoon hours, we see there is a little bit of maybe some convectively enhanced echoes here, but maybe there's a little bit of a boundary hanging around here that's post MCS, maybe a little bit of moisture return, maybe a combination of the two. Overall, deep layer shear, we have much stronger deep layer shear that develops into the afternoon, evening. This is probably mostly convectively contaminated, but generally looks like we've got 30 knots of flow or bulk shear kind of moving through the area. That should be sufficient enough to maybe initially generate some supercells or multi-clusters of storms here. I want to take a quick look at overall soundings in the area of interest. We're going to go ahead and just use the helicity kind of pinpoint an area of interest a little bit, cherry pick if you will, have some fun. Let's go ahead and pull a sounding here. Yeah, and this actually is not too surprising. It seems like the HRRR really wants to overmix. You actually get a little bit of an upside down low-level hodograph, but overall it's pretty much just a straight hodograph with a big inverted V. I think if you are going to maintain multiple storms in this environment, even early supercell or two, the ultimate evolution will be to go and turn into a large MCS as this type of a sounding will be very favorable for an intense downdraft and strong cold pooling as that air evaporates and rapidly accelerates into the ground. So maybe the first hour or two of a storm's life that's isolated might develop some supercell characteristics given a little bit, I'll say marginal decent bulk shear and steep low-level lapse rates. Should help kind of keep things being convective and more supercellular initially and probably develop into more of an MCS as we get into the later parts of the afternoon. And we can go ahead and actually pull a sounding now a little bit later. We'll pull one again in the same area at 6 p.m. See kind of what's looking like here in that southwest Nebraska area. And seems like we get a little bit better low-level hodograph here, but again, the damage is done with the overall plowing MCS. These are some rough profiles, pretty marginal to weak instability, maybe up here. Further south into Kansas, we see that there's, yeah, we're dealing with a lot of elevated profiles, high LCLs at best, and some dry low-level conditions. So I think the main factor to pay attention to here is I think you're going to develop maybe a couple of storms initially and develop into more of an MCS through the evening. So that seems to be the threat going into the day here across Nebraska, northeast Colorado, northern Kansas. Just taking a quick nod to the south, see if we can get a kind of idea what's going on down here. Let's pull a little bit better sounding because I think I am behind some convection here. Go ahead and use just dew point here. Or excuse me, that was temperature. There we go. Yeah, seems like there are some storms. So let's go ahead and pull a sounding over here by Garden City. And seems like we've got the same story here. A little bit better, maybe elevated instability, so hail would definitely be a major threat. But with these inverted V-shaped soundings and high, super high LCLs, I would expect mostly a initial cluster or two that develops into a probably decent MCS with some very strong wind gusts. Probably wouldn't be surprised to see some 60 to 70 mile per hour wind gusts in the eastern high plains, western central plains as probably the predominant threat. Maybe hail initially, maybe a tornado if you're lucky in that southwestern Nebraska area along that boundary. It's going to be important to see how that moisture return behaves. And we can take a look at that as we kind of flip through the models just really quickly at the surface before we get into some reflectivity and see kind of how the models behave. Overall, seems like the wrap wants to get the moisture back into southwest Nebraska and even getting into southwest Kansas too. So that would be an exciting turn of events, which would totally change the overall thermodynamics. Just taking a quick look at this. A little bit better, still pretty warm, much larger instability. Overall, though, a fairly straight hodograph, and given the overall temperature spread here, this would still sustain strong wind gusts and probably a maybe even a strong downdraft given the precip loading and a lot of precip in this overall profile. Looking up a little bit further north, actually a much better sounding, although the hodograph would probably favor more left splits and left movers, funny enough, but deep layer shear seems to be sufficient enough for maybe a couple transient supercells, very large instability, and this would actually be much more favorable for a very fun supercell that might persist a little bit longer instead of just auto turning into an MCS. But overall, I think it's going to very much depend of what that moisture return behind this potential MCS, right? Does that MCS plow all the way through Kansas? Or does it weaken and die out before plowing all the way through? Do we get that moisture to surge back in? But even if that moisture does really make it in, I think the damage overall is mostly done. I don't think we're going to see a robust tornado threat here over the plains, but if this moisture does come in, I think for those storm chasers that love maybe some structure fests, this would definitely be an interesting setup to pay attention to, given sufficient deep layer shear, and if we can get the better moisture, maybe a better thermodynamic profile for maybe some storm structure, especially here in this kind of I-80 corridor here.
Great forecast, Hunter. And I want to remind folks before we move into a couple of the questions that I have for you that you can click the join button down below this video. It's only $3 for our channel membership, $4 if you happen to be on an iOS device, just because Apple has to take their cut. But it is a great way to show your support to the Storm Chaser Coaching Project. Lets us know you're enjoying the content, and you get some awesome perks as well. You can check those out if you're interested. So click the join button down below. And Hunter, let's get into some questions that I have for you here.
Yeah.
First of all, terrain features, obviously always a big deal when we're talking about storms that could potentially be in the eastern half of Colorado. Is this setup going to trend far enough to the west, or are we pretty much removed from things like the, and I always get this wrong, the DCVZ or ABCDEF, whatever it's called,
There you go.
that sort of stuff, the Palmer Divide, all that jazz. Do we need to worry about any of that stuff today?
Yeah, I don't think that's going to be too much of an issue. I think even with the wrap being the most robust with this, we can look at 3 km NAM here as well. But I think this moisture return is going to pretty much hug the Colorado border where there isn't too much land variation. Those larger like hills and valleys that we get with the Cheyenne Ridge here in Wyoming, northern Colorado, the Palmer Divide, which sits over kind of central Colorado. Seems like we're going to be enough removed where I don't think maybe upslope or landscape is going to do too much to affect this setup. This is pretty much just nice flat rolling plains that slowly kind of begin their upslope into the higher terrain.
I was also really interested earlier on in the forecast when you were talking about how the stronger 500 millibar winds are actually shunted off to the south away from our area of interest, that sort of triple point with the potential lake breeze that you were mentioning. So, If we see some of that 500 millibar flow start to edge up north a little bit more, would that maybe influence a decision to maybe go a little further south to try to actually get your storms in that area, or is that even not necessary for the day?
No, I think that's an absolutely great observation. Normally, with like traditional cold cores, you'd have both the open warm sector that you can go chase and the cold core setup because you kind of get this overlap of both occurring usually at the same time. It's very rare that you get a cold core that just happens by itself without anything else happening further southeast. If this flow can really kind of nudge a little further north, I think it'd actually enhance the overall setup, give it a little bit better deep layer shear to really help make sure the mode is purely supercells rather than kind of clustering small multicells. That would definitely help the setup a lot further north because one of the major things we talked about is really poor lapse rates. So you need to kind of maybe overcome with the overall shear profile to work through that maybe weaker thermodynamics.
Very interesting stuff. Appreciate you breaking that down. And let's go ahead and move over to the SIMREF Showdown. That is simulated reflectivity for those who might not be familiar with the term.
Let's go ahead and start off here to the north. First, just looking at our pseudo cold core type of setup. As we go through the night here, we see that there are complex of storms here. And an important thing, I think I'm getting ahead of myself, is an important thing to always do before you look at simulated reflectivity is you should always compare notes to what's actually happening in the real world because it gives you an idea, is the model doing a good job, right? You're just doing some simple clerical work to say, hey, is it doing a good job? Flipping over to the radar, up on the north, and bam, look how much identical that was to the model. So we've got plenty of storms here over the Dakotas. Seems to match perfectly what we were talking about. So I think we are green light to go ahead and just jump right into the model. Almost identical. So seems like we've initialized perfectly. Going into the overnight period, seems like we've got an MCS kind of blow through Watertown and an MCS that kind of rides along the US Colorado or US Canada border here. Seems like that kind of dies out as it escapes the better flow, and we start getting additional storms in this warm advection regime that kind of go up the slope of the warm front, so you get all these showers and thunderstorms out ahead of the warm front. You can see that this nice curl kind of goes like this, and so our upper low surface seems to be right in here by the morning hours. And as we go in, we seem to get this little bit of an unzipping down the occluded boundary into the early afternoon hours, and actually, funny enough, develops a nice little supercell here right in this northeastern part of Minnesota. And with this little kind of darker area, this seems to indicate that this might be a rotating storm as well. So it seems like we might develop some transient supercells right along that occluded boundary and seems to be riding along it as it continues to move off to the east. We do see additional storms develop further southeast towards Duluth, maybe. So we need to really pay attention to what kind of happens with this lake and does it develop a lake breeze boundary at all? Because then we could definitely locally enhance maybe a tornado chance here. Seems like we develop storms again across northern Wisconsin, and the day pretty much ends as the storms kind of run out of instability and heating, and the upper level low stays real nice and close. You can see that nice spiral as the storm system overall moves in. So seems like that's pretty much expected based off of our forecast that we've looked at previously. So let's go ahead and take a look at some other models, right? Let's do some comparison. We'll pull up the RRFS here and blaze through this. Seems like the same idea. We see storms unzip down the boundary overall pretty much at the same time in the early afternoon because there is no cap. But notice the RFS is a little bit more vigorous on maybe the interface of the cold front, warm frontal boundary having maybe a storm as well. This would also be a very key spot to watch if we can get a storm or two to develop because this can easily be a supercell as well, riding along that warm frontal boundary, which can easily enhance the overall tornado potential. So it seems maybe there's I'll say closer target for those who live in Minnesota and particularly Minneapolis area where I know a lot of storm chasers are from. But overall, maybe too much convection up further north, which again, we talked about that, right? No cap and very weak lapse rates, very easy to generate a lot of storms. The RFS seems to be maybe favoring that type of solution. But we still see potential storms along the lake boundary, so we'll need to potentially watch for that as well, kind of picking up on that same thing. Going ahead and jumping over to the 3-cam NAM, if I can find it. There it is. Seems like the same type of thing we've talked about, but the 3-cam NAM does seem to favor, which, shocking, not a giant MCS. It actually develops supercells, as you can see here, maybe a couple of rotating updrafts in the overall northeastern Minnesota area. and storms developing down towards that kind of interface boundary of the cold front and warm front into the Minneapolis area. So I think there's plenty of reason to be looking out over this whole area. Maybe SBC expands the 2%, maybe a little bit more south towards Minneapolis here based on maybe we see a more confidence in some storms down that way. But seems like we're getting towards a pretty good confidence that we should see maybe a few supercells, two or three supercells in general in this northeastern Minnesota area, northwestern Wisconsin area through the northern mode. So it seems like we've got a lot of good agreement. So I think the forecast seems pretty solid based on the overnight forecast. I would expect potentially a tornado or two kind of in this zone here. If I was a local chaser, I'd be pretty excited about this, but if you know anything about this area, good luck. I hope you brought your drones because you're going to need them because this is all heavy forest. So good luck to those out chasing. I think you're going to have maybe a decent chance at a tornado. I'm excited for you. So I look forward to seeing what people kind of come up with. Taking a look now further south, let's go ahead and take a look back at the HRRR that we talked about that morning MCS. And if we pull up, we'll start with the 0Z here. We see develops a little bit of an MCS, kind of plows through all the way to the Oklahoma border here by the early morning hours. And we see development of, funny enough, supercells actually further northeast than I had initially thought. So this is actually pretty exciting. This would be much deeper into the actual surface moisture that would be held off to the east. So let's go ahead and actually pull a sounding ahead of those because I had failed to do so previously. And looking at the overall profile, this would definitely support a supercell. This is much stronger bulk shear overall. Looking at the overall thermodynamic profile, plenty of instability, very saturated, so I would expect lots of storms to probably develop around your storms you're interested in. Not too bad of spreads here, not super crazy lapse rates, sufficient, but not super intense, but good enough. But a lack of EML means that you're probably going to be fighting a lot of other storms in the area and in the region. And given the overall saturated profile, I expect these storms to probably be pretty wet and full of precipitation. So maybe don't expect an LP, probably expect some type of HP storms here across maybe central Nebraska. So exciting news. This is actually really exciting if you're looking to chase this. Just nodding down further south, seems like we get some type of convection, actually maybe generating a Leote supercell here in Kansas. That's going to be interesting to see how that kind of goes out. Pulling a sounding near that storm. See again, similar story. We get some sufficient bulk shear, so we should maybe see a transient supercell too. But big inverted V's here will make these storms very easily capable of producing a strong downdraft, strong cold pooling. So they'll probably go upscale relatively quickly within a couple of hours after initiation. But maybe you can eke out a little supercell here with a little bit more dry air at the surface. Maybe it'll just be a little bit more visible before everything kind of turns to mush and big old HP MCS that plows through the area for those down that way. Let's go ahead and jump now over to the RFS and kind of compare notes here. And we get to the afternoon hours. Seems like we get initial supercell development again further northeast and maybe a bit further north. So it seems like the RFS likes this moisture return coming in. But these supercells seem to just completely die out, so that could just be a model quirk. But given the fact we had robust supercell development by the afternoon, I think that would probably continue off to the southeast as long as the instability remains intact. And seems like we get some storms develop off the higher terrain off to the west, which would probably be very elevated convection that tries to move into deeper moisture, but will probably just become an MCS plowing through the eastern Colorado into western Kansas. And further south seems like, again, just plowing into a big old MCS, more or less immediately 1 to 2 hours after initiation. No surprise there. Jumping over to the 3-cam NAM as comparison again. Through the morning, we see that the MCS kind of plows through. And the 3-cam NAM says, no, screw you guys, no storms for you, unless you want to shoot lightning out by Cheyenne or play a very high-based MCS out in the Panhandles area. So the 3-cam NAM is your hater if you are a chaser out here. If you want to chase a good storm, you hate this model, but it seems like there's a little bit of disagreement to see how this MCS kind of plays into the overall morning evolution. So I think that's going to be a key feature to pay attention to. So models are a little bit, I don't want to say out to lunch, but there is some disagreements overall, I think, to how some of these key early features play out that you're going to need to pay attention to. But overall, I think the forecast is pretty straightforward. Damaging winds is going to be the probably number one threat. Hail for any initial supercells, especially in the afternoon. Maybe you're lucky with a tornado if depending on if one model favors supercells and you get lucky and that's the actual outcome. Maybe we can see a brief tornado, but I'd be very interested to see what happens in central Nebraska. Maybe get some cool structure from some HP supercells to be chasing. So I think that is the overall outcome. I think the overall forecast, despite being a lower end day, I think it's very interesting. I think you got multiple different types of things you could potentially chase. And I think your best bet for a tornado is definitely going to be up here in the Duluth area near the lake.
Remember to check out those links in the description below, and then watch another video.